Over the last couple lessons, we have been working on sample space, coming up with outcomes to experiments, chance experiments. And then we were talking about finding probability with these outcomes when everything is equally likely. So, what happens when the outcomes are not equally likely? Keyword not equally likely. Okay. So not everything is going to come out like perfect. Like the spinner's not always going to have the same number of sections. What do we do in those cases? And that's what this lesson is going to focus on. Okay. Again, probability though is still our favorable outcome, right? Like what we want over total. Okay. Number of outcomes divided by the number of outcomes in sample space. All right. That's what I just said basically, a little differently. What about when they're not equally likely though? We need a different approach. And that's what we're doing here. So Jenna is going to go to the farmer's market. I can maybe get this to scroll correctly. And she's going to buy bananas. The number of bananas she might buy and their probabilities are shown in the table below. Okay, so what the heck does that mean, right? Well, the probability is 1/10 that she's going to buy 0 bananas. If the probability she can buy 1 banana is also 1/10. Now remember, we can leave this as fractions. We can leave it as decimals. We can also turn them in percents, right? So I could move that over twice and say that this is 10%, and this is 10%, and this is 10%, and this is 20%. Okay, so feel free to do that if that's more comfortable to you, okay? But you can see that this is just the probability of how many bananas she's going to buy. 3 bananas, 20%, 5 bananas, 30%, okay? So they're not all equally likely. It's a higher percentage that she's going to buy 5 bananas than it is that she's going to do 0 bananas. Doesn't mean she won't get 0 bananas, right? But that's that. They're just not all equally likely, right? So what is the probability that she buys exactly 3 bananas? Now, guys, it's going to be really important that we pay attention to these words in here, right? Exactly 3. Is exactly 3 mean, I'm going to grab 4? No, it means I want 3. So if we look, 3 bananas, so we can see it here, okay, is 0.2, 2/10. Or if you wanted to, if your comfort level is percents, 20% is fine, okay? What is the probability that she does not buy any bananas or 0 bananas, right? If she's not buying any, it's 0. Well, that's right here. And I'm okay, and understand, guys, I'm writing both 1/10 and 10%. You don't have to write them both. You just needs to be one or the other, right? Okay, so remember what I said. We have to be very careful, right? So what is the probability that she is going to buy more than 3 bananas? Okay, so we have to stop for a second here. If she's buying more than 3, is she buying 3 bananas? No. She's not buying 2 bananas. She's not buying 1 banana. She's not buying 0 bananas. You don't have to cross them out. Sorry. I'm just doing this to show you here. So if she's going to buy more than 3 bananas, she's either going to buy 4 or 5 bananas, right? Well, 4 bananas would be 0.2. 5 bananas would be 0.3. Here's the key. You add them. You're going to add the probabilities together, okay? We want the probability that there's going to be more than 3, right? So we want the total probability. 0.2 plus 0.3 is 0.5. Or again, if you feel comfortable, 50%, right? Remember, you could say 20% plus 30%, and that would give you 50%, okay? Very careful with wordage. What is the probability that she buys at least 3 bananas? So if she's buying at least 3, again, you don't have to cross them out here. I just want you to explain it. Not 0. Right, that's not at least 3. 1 is not at least 3. 2 is not at least 3. Is 3 at least 3? Yes. Is 4 at least 3? Yes. Is 5 at least 3? Yes. Okay. So in this case, she's going to buy either 3 bananas, which is 0.2 or 2/10, or 4 bananas. So again, I'm going to add it. That's 2/10. Or 5 bananas, which is, nope. Okay. So again, this is 3 bananas, just to kind of have it in your notes. I did not spell bananas right, sorry. 4 bananas, and 5 bananas. If you understand it, you don't necessarily have to write it down, but that's where these three things are coming for. You add that all together, 3, 4, 5, 6, 7. That ends up being 0.7, 7/10, or 70%. Okay, so what is the probability that she does not buy exactly 3? Okay, so if it's not exactly 3, 0 is not exactly 3, 1 is not exactly 3, 2 is not exactly 3, 3 is exactly 3, 4 is exactly 3, and 5 is exactly 3. Okay, so we're going to do this a couple different ways. The first way is we can be doing what we've been doing, right? We can add up our probabilities, not including the 3. And so if you do that, 1, 2, 3, 4, 5, 6, 7, 8, that works out to be 8/10. All right, not a problem. We can do that, right? But let me show you something in this next part here. Notice that the sum of the probabilities in the table is 1 whole. This is always true. When we add up the probabilities of all the possible outcomes, the result is always 1. So let me see. Okay, I'm going to get rid of this cross out here. So, if I add all these up, oops, not what I meant to do. Okay, if I add all of these up right here, right? 0.1 plus 0.1 plus 0.1 plus 0.2 plus 0.2 plus 0.3, 1, right? If you add up the percents, 10 plus 10 plus 10 plus 20 plus 20 plus 30, 100%, right? This has to account for all of them. So when you add all these up, it equals 1. If you add all the percents up, it equals 100%. Because that's all of it. It always has to, remember I said it always has to add to 1. So if you think of it as all being 1, if we don't want, if we want to find probability of something not occurring, we can subtract. What does that mean? I know that all of these together is 1. So if I want to take out 0.2, I could go 1 minus this probability of buying 3, right? So that would be 1 minus 0.2. And guess what 1 minus 0.2 is? 0.8, or 80%. Okay, so you can either add them all up, or you can just go 1 minus it, because all together it has to equal 1 or 100%. Okay, so let's look at another example. Jenna's husband Rick is concerned about his diet. On any given day, he eats either 0, 1, 2, 3, or 4 servings of fruits and vegetables. So the probability that he's going to eat 0 servings of vegetables and fruit is 0.08, okay, or 80%. 3 servings, 0.39, okay? So we're going to do this the same way as we did before. On a given day, find the probability that he eats 2 servings of fruits and vegetables. Okay, right there, 0.28. And I'm just going to leave that. You can change it to a percent if you want it. How about more than 2 servings? This is that one again. Where is more than 2? Well, here's 2, right? Again, you have to cross things out. More than 2 would be 3 and 4. So we're going to add. We're going to go 0.39 plus 0.12. Oops, let me clear it out here because I apparently didn't hit the... There we go. That didn't work. Sorry. Let me try again. This is what happens when you rush. How about 0.51? Okay. Or 51% if you were turning into that. How about at least 2? Well, if it's at least 2, it's just not 0 and 1. 2 is at least 2, 3 is at least 2, and 4 is at least 2. So we're really going to have to watch our words there, right? So I'm just going to add them together. 0.28 plus 0.39 plus 0.12. Type that into a calculator. I've done that already. I won't make you sit through me messing up again. And it's 0.79. Okay? Now, let's use that idea of all of these adding up to 1. All right. In fact, I am going to use my calculator one more time to show you. If I go 0.08 plus 0.13 plus 0.28 plus 0.39 plus 0.12, notice it equals 1. When I add all of these up, it equals 1. So if I want to find the probability that he does not eat exactly 2, probability of, I'm just going to say not 2, I can go 1 minus the 2. Okay, I can add all of these up, or I can just go 1 minus 0.28. And when you do that, you get 0.72. If I were to add these 4 up, I'd get 0.72. So it's just kind of a shortcut way. Okay? So again, with now probabilities, chance experiments that are not, the outcomes are not equally likely, we have to use the information they're given to be able to figure out what the percent or what the probability is that something happens.